Hello students, so welcome to the lecture number 10, and in this lecture we will discuss about the last type of quadrilateral, which is known as trapezium. Okay, we have discussed every 5 previous type of quadrilaterals such as parallelogram, kite, rectangle, square and rhombus, and today's time is for trapezium. So let's understand what is a trapezium and what are the different properties of that trapezium. Okay, so before starting with trapezium we have to draw the figure of a trapezium. Okay, so this is the figure of a trapezium. It looks like the top of a house. A, B, C, D. So, like the square, the rectangle, the rhombus, parallelogram and kite, a trapezium is also a quadrilateral. First of all, it is a quadrilateral, right? So, the properties of trapezium. Properties. It is a quadrilateral. Okay, it is a quadrilateral. And the second property, out of the four sides, AD, AB, BC and CD, only one pair of opposite sides are parallel. Only one pair. It is how many pair of opposite sides? It has two pair. ADBC is first pair and AB and DC is second pair. So out of this two pair of opposite sides, only one pair of opposite sides are parallel. So that which pair? AD and BC. So only these two pairs are parallel sides and these two pair of opposite sides are non-parallel sides. That means they are not parallel. Okay. So you can write it, only one pair of opposite sides are parallel. Only one pair of opposite sides are parallel. Okay, so you can write AD parallel to this, and these two sides are non-parallel. Okay, maybe they are parallel, but in such cases, in this case, AB and BC are non-parallel. So AB non-parallel to DC. Clear? This is the second property. Now third property. In case of trapezium, we can say the value of each interior angle. Like with the rectangle. In rectangle, each angle is 90, but here we can determine whether each angle is 90 degree, yeah, 45 degree or 60 degree or 120 degree. Okay. And second thing is, in case of a trapezium, if we draw two diagonals, let's say this is AC, and the diagonal, let's say this is BD, then the length of AC and the length of BD, they may be equal or they may not be equal. Okay, they may be equal or they may not be equal. We can determine after measuring such distance. We can say yes, they are equal or they are not equal, but we cannot verify whether the two length of the diagonals are equal or not. Okay, so here also you can write the length of two diagonals may or may not be equal. Understood? Next is fourth. Here, in case of a trapezium, the two diagonals are not bisecting each other. They are not the bisector of each other. It means both the diagonal meet each other at a common point. This point is point of intersection. Now at this point, the diagonal AC is not bisected. Okay, as you can see, this distance is very small and this distance is very large. Yes or no? So AC is not bisected at O. Similarly, the distance or the length of the diagonal BD is also not bisected at O, because this distance is very small and this is very large. So at the point of intersection, the two diagonals do not bisect each other. Okay. So at the point of intersection, At the point of intersection, the two diagonals do not bisect each other. Do not bisect each other. Understood? So out of the four property, you have to remember just 1, 2 and 4 property. Third property is not necessary. Okay. Because the length of the two diagonal may be equal or may not be equal. We can't say before measuring the distance. So you have to remember just 1, 2 and 4 property in order to be a trapezium. These are the basic properties of a trapezium. Okay. So here what we found? We found in case of a trapezium only one pair of opposite sides are parallel and another two pair of opposite sides are non-parallel. But a case arises here. What is the case? If the length of two non-parallel sides are equal, like this. See, what I have told you, if the length of two non-parallel sides are equal, it means if this and this are two non-parallel sides, if this is 4 cm and this is 4 cm, then in such case, the name of the trapezium is changed. It is known as isoscale trapezium. What is it? It is isoscale trapezium. If the length of two non-parallel sides are equal, then it is known as isoscale trapezium. Note it down. Note. Okay. So write it. If the length of two non-parallel sides of a trapezium are equal, then it is called what? Isoscale trapezium. Isoscale trapezium. Right? You got understood? So, in order to be isoscale trapezium, what is important? The two non-parallel sides must be of equal length. Now, the basic properties regarding trapezium has been finished. Now, we'll discuss about another thing, that is whether a trapezium can be a parallelogram or a parallelogram can be a trapezium. So, let us discuss about this. So, the first question that arises here is, can a trapezium be a parallelogram? It means, in order to be a parallelogram, a trapezium has to follow every properties of a parallelogram. So let's verify whether this statement is true or false. Okay, since it is a trapezium, it is a parallelogram. Now, in case of parallelogram, it is a quadrilateral. Now, trapezium also quadrilateral. In case of parallelogram, the opposite sides are equal, but here the opposite sides are not equal. Okay, they are not equal. So it doesn't satisfy the second property. Now, third property. In case of parallelogram, the opposite sides are parallel, but here only one pair of opposite sides are parallel, but these two pairs are not parallel, they are non-parallel. Okay, that means a trapezium does not follow the all properties of a parallelogram. So a trapezium can never be a parallelogram. So you can write no. A trapezium can never be a parallelogram. Done. Coming to the question number 2. Can a parallelogram be a trapezium? In order to be a trapezium, a parallelogram has to follow every property of a trapezium. So let's verify whether this follows all the properties or not. So in case of a trapezium, it is a quadrilateral. Now parallelogram is also a quadrilateral. Second property is that in case of trapezium, only one pair of sides are parallel. And in case of parallelogram also, you know, one side of sides are parallel. That means it satisfies every property of a trapezium. So you can write yes, a parallelogram can be a trapezium. Okay. So the simple answer is yes, a parallelogram can be a trapezium. Understood?